Okay. Hi everyone, and welcome to the presentation of design and operation of the greenhouse facility. My name is Firdaus Jinabade, and I'm the creator of this greenhouse facility in the lunar habitat of Mission 175 but Habitat Marte. So I'll walk you through the internal design of the greenhouse facility, the machines for the operation, and the possible resources to generate in situ or transport it from Earth, and the organizational structure of the workers or astronauts, and their position, profiles, and duties, and their training program, YouTube videos to train astronauts how to operate the mission, and resources needed for 1 week, and guidelines to be provided to other facilities such as main station or engineering facilities, etc., and specific protocols of the facility and of the safety and for occupancy, entertainment, and for food microproduction and for 3D printing. And lastly, we'll delve into the most important topics. Those are technologies and outputs that could be applied to Earth, and guidelines to be applied to daily life on Earth, and impacts to sustainable development goals. So we'll first explore the internal and external design of the greenhouse facility. So this is the external infrastructure of the greenhouse facility I have created using AI. It is three-floored level and circular, 8 meter in diameter, and it is circular because for the space to build, and also the lunar habitats facilities are going to be round in shape. So on the first floor we'll have the dormitory area here, some toilets, and a vertical garden, and also a 3D printing area. And in the second floor we'll have a kitchen area and the dining area. This should be big because the astronaut should be able to sit at once and eat. And in the third floor it will be for multi-purpose use. It can be for the desktop area to control the system, and there could be some cupboards to put necessary things, and there is the sitting area. And the next thing we'll delve into are the machines necessary for the operation of the installment. And first one, this is the hydroponic and aeroponic system to grow the herbs and plants for the greenhouse facility to feed other facilities, astronauts, and other. And this one is the environmental control system to regulate the humidity, temperature, and CO2 levels of the whole facility or the whole lunar habitat. And this one is the nutrient delivery system. It is more AI, future AI generated, and this will supply nutrients to our plants that are going in hydroponic or aeroponic systems. And last one is the 3D printer, of course, because it is the most necessary machine in the greenhouse facility to print important tools, as we can't carry everything to Mars or Moon. We will print it in the 3D printer when we arrive there to to save the space. And third, the possible resources to generate in situ or transported from Earth. The in situ resources are water and oxygen. Their generation could be extracted from lunar ice, as we know that we have finding ice on Moon or Mars, and it could be recycled from astronaut waste, urine, and sweat. And their management could be the recycling system, incorporation of filtration and purification units to ensure clean water supply for plant irrigation and human consumption. And the storage tanks for their management, secure storage is necessary for the water, as we should not waste water there. And oxygen generation is produced through photosynthesis by plants and electrolysis of water. The photosynthesis of plants can be achieved through the hydroponic and aeroponic systems. And their management could be devices that extracts and store energy, and air circulation system ensure even distribution of oxygen throughout the habitat, because every facility should get the needed oxygen. And the one transported from earth are the initial water supply. Their management could be the storage containers, secure space efficient water containers for initial use until in situ resources are established. So this is a pre method until we establish the in situ resources there on the lunar surface. And the next thing is specialized nutrients and fertilizers. Their management could be storage, securing storage for imported nutrient supplies, that the imported nutrient supplies, and the usage protocols could be carefully measured and rationed to supplement in situ nutrient resources. This should be rationed because we should not waste the specialized nutrients, as we can't go back to earth to get those. And the organizational structure of the astronauts could be the greenhouse manager, the botanist, the technicians, and the supporting staff. This is the images I have extracted from AI. This is the middle one would be the manager overlooking on all the tasks, and these are the botanists and the technicians to repair and to maintain the machines, and the supporting staff could help all of them. Their positions, profiles, and duties could be: the greenhouse manager's profile could be experienced professional in greenhouse operations with strong leadership and organizational skills. Talking about leadership and organizational skills, I believe that these skills should every astronaut have. And talking about his or her duties, he will coordinate daily activities, ensure all tasks are done effectively or on schedule, and he will manage resources and inventory, oversee the use and storage of resources, and ensuring supplies are maintained. Basically, as a manager have to overlook everything and manage everything. That's how greenhouse manager could be. And botanist would be the researcher. His profile or her profile would be expert in plant biology with knowledge of hydroponics and aeroponics and experience in controlled environment agriculture. His or her duties would be to conduct research in the greenhouse facility on plant growth, study and optimize plant growth under lunar conditions, and monitor. That's what we are currently doing on the ISS station right now. We can enhance and advance these missions on the lunar habitat and monitor plant health, regularly check plants for signs of stress or disease, and implement corrective measures. This is important because if we overlook what the plants are going through, then we'll not have a good herbs, good plants in the end, and we'll have to lack the food. And the third one would be the technician. His profile would be skilled in mechanical and electrical system with experience in maintaining and repairing greenhouse equipment. Basically, technician is important for the repairing of the machines and maintaining it daily. And his duties would be ensure proper functioning of system. He has to look over if the machine is proper working or not, and who he would perform routine maintenance for daily, conduct regular checks and repair to prevent system failures. And the supporting staff would be the generalist with a broad range of skills capable of assisting in various operational tasks. Various operational tasks in the sense of helping the botanist, the manager, the technician, and other people. And their duties would be helping with planting, harvesting, and care, assist in all stages of plant growth and maintenance. They would stay until all the whole the plant grow, and they will manage composting and waste recycling, handle the processing of organic waste into compost, and manage recycling process. They will be the great hand in the composting system of the whole facility or the whole lunar habitat. The next one will delve into the astronaut training program. As we know, training is important to do a mission or anything, and our objective will be to equip astronauts with the necessary skills and knowledge to manage and operate the greenhouse facility effectively. Because if we miss the training, we cannot do the mission effectively. In the week one, we'll teach them about fundamentals and system training, and from starting from the day 1 to 2, would be the introduction of the mission, introduction to greenhouse operations, overview of greenhouse facility, layout, key systems, and daily operations, and also the safety protocols, the most important one, the emergency procedures, personal protective equipment, and handling hazardous materials. As we talk about greenhouse facility, there is the great risk of hazardous material because we use chemical to do the mission, so it is a risk of hazardous material, so we should train them about those things. And day 3 to 4 would be the plant biology and growth, basics of plant physiology, and understanding plant needs and growth stages, and also the knowledge about hydroponic and aeroponic systems, how they work, how to use them, and how to maintain them. And to the day 5 to 6 will teach them about the environmental control system, the that big machine, and will in that will teach them about climate control, managing temperature, humidity, and CO2 levels. Yes, as we know that environmental control systems regulate daily humidity, temperature, and how to manage that machine will teach them. And also LED grow lights, adjusting light spectrum and intensity for optimal plant growth. Yes, we'll be growing those plants in the stationed area, so we'll give them LED lights, so to adjust those light we'll have to train them. And for the day 7 will be resource management, in that water recycling, filtration and purification process, nutrient management, composting, and automated nutrient delivery systems. This is the main thing because transporting nutrients to plants is necessary, as we can't grow plants without them. And for the week 2 we'll have a practical session, practical training, and emergency preparedness. Emergency preparedness is very important because the risk of that in outside of earth is the most. And on the day 8 we'll train them about the equipment maintenance, the maintaining machines. Routine maintenance would be their daily checks and minor repairs on greenhouse systems, and troubleshooting, identifying, and fixing common issues with hydroponic and aeroponic systems. On the day 9, we'll train them about 3D printing and technical skills. 3D printing is the most important thing that should be taught to every facility because 3D printing is necessary on the lunar habitat. And creating spare parts from the 3D printers. And on the day 10, we can train them about harvesting and plant care. And day 11 would be the emergency drills again. Emergency scenarios are something simulations of potential emergencies, system failures, contamination, etc. So to train them about these, to give them knowledge, it would be helpful. For the response procedure, steps to take during emergency to ensure safety and minimize damage. Uh, for the day 12 would be the review and evaluation. It is a more examination type. Will take their evaluation to ensure that they have the proper training and they have equipped those skills and they know now how to do the operation and the mission effectively. We'll test their knowledge assessment and we'll also get a feedback session. Some YouTube videos to train those astronauts are here as listed. I have uh, put some links of them. First one would be the introduction to hydroponics and aeroponic system, as this is the main role in the greenhouse center. And second one would be the climate control and environmental systems in the environmental system machine. And third one would be the LED grow lights, how to manage those lights to grow plants. And the resources needed for 1 week for the greenhouse facility would be water, 14 liters per astronaut per day. That would be total for 1 week, 98 liters. And nutrients and fertilizers for the plants would be total for 1 week would be 1 liter. And seeds and plant cuttings total for 1 week would be small batch, approximately 50 seeds or 10 cuttings. We'll sow 50 seeds or and cut 10 plants like that. And the 3D printer filament, the thing that we put in the 3D printer to print something, would be needed in 500 grams per week, and the power to run those machines and to run whole facilities would be total for 1 week would be 10 kilowatt per hour. And medical supplies is enough for a standard kit for 1 week. And compositing materials, total for 1 week would be minimal, just daily plant trimmings. And maintenance tools would be a basic toolkit. That's it. And the guidelines to be provided to other facilities for the entire station for lunar habitat would be resource sharing. So what we have con- constructed in the greenhouse facilities, it would be shared to other facilities, like coordinate water and nutrient use with other facilities to prevent shortages, share excess produce from the greenhouse to supplement other food supplies. And also the waste management, the greenhouse would be responsible for waste management of all the facilities. And environmental control, maintain consistent temperature, humidity and CO2 levels in all across all the lunar habitat. It will be the responsibility of greenhouse facility to control, to regulate the whole temperature, humidity, CO2 levels. And communication protocols, establish clear communication channels for reporting issues and coordinating activities. As the sense, clear communication is important because even a minor mistake can lead to a big problem there. And emergency procedures, yeah, in the case of emergency every facility should come up with the help. And the specific protocols routines for the greenhouse facility would be the daily plant care routine, that would be for morning. And maintenance routine for daily, as we have to check the machines they are working properly or not. And for weekly perform equipment maintenance and refill nutrient reservoirs. And waste management routine would be for daily, emergency checks would be for daily. And protocols of safety, is in this first one would be the personal protective equipment, wear gloves and mask when handling plants and chemicals as they can be hazardous. And emergency procedures, follow posted emergency evacuation routes, conduct regular emergency drills are important. And equipment safety, disconnect power before servicing equipment, as if we are cleaning the equipment we should disconnect the power, as there can be a risk of current shocks, like that. Use tools and machinery as per manufacturer guidelines, so we should follow the guidelines there. And hazardous material handling, if we are handling a poisonous material we should store chemicals securely and label them clearly. And dispose of waste properly following safety protocols. Protocols for occupancy and entertainment. For occupancy guidelines, maintain a maximum occupancy of 4 astronauts in the greenhouse facility at a time. Because if we put more than 4 astronauts, there could be a problem by shifting those with others. Schedule shifts to ensure continuous monitoring and care of plants. Yes, care of plants is the most important one in the greenhouse facility, as this is the mission of greenhouse facility. And for the entertainment, allocate a small area for recreational activities like reading or light exercise. This can help the astronauts relax. And also provide access to digital entertainment, ebooks, movies, music, etc., to help astronaut relax during the day. And protocols for food production would be the crop selection. We should choose the fast growing crops, as we are doing missions other than earth. So the crop should be high nutrition plants such as lettuce, spinach and herbs. And also rotate crops to ensure a continuous supply of fresh procedure. And growing methods could be utilizing hydroponic system for efficient water and nutrient use, as we cannot use more water on the habitat. And we have to regularly monitor and adjust environmental conditions to optimize plant growth. For harvesting, we'll harvest plants at peak maturity for maximum nutrition, and use harvested plants immediately to or store them properly to maintain freshness. The protocols for 3D printing are as follows. First one would be the preparation. We'll select the filament, what type of filament we are putting, and ensure the 3D printer is cleaned and calibrated. And second one would be the printing. Load the design file and filament. We'll load the design, proper design, what we have to print, and we'll start the printing. And post processing will remove the printed item carefully as it does not broke, and inspect for defects and may make any necessary adjustment. If there are defects, we should make necessary adjustment to ensure proper printing. The technologies and outputs that could be applied to earth are the hydroponic and aeroponic system, as we have used those machines there on in the greenhouse facility on lunar habitat. It could be used here on earth. Their application could be efficient, soil-less farming techniques suitable for urban and indoor farming. As we can see in the urban area, in the modernized cities, there are no yields or farming. So this hydroponic and aeroponic system can be a beneficial part for the large urban areas. And its output could be increased food production in areas with limited agricultural land and reduced water usage. It will also reduce water usage as we are facing lack of water. So this is the great point. And the environmental control systems, its application could be advanced climate control system for greenhouses and indoor farming, and its output could be optimizing growing conditions leading to higher yields and consistent quality regardless of external weather conditions. Environmental control system is a more man-made, so the plants grow are quality based, a consistent quality, because the we are providing those environment with a man-made machine. And the water recycling system would be closed loop water purification and recycling for agriculture and residential use. This is also important for more urbanized cities, and its output would reduce water waste and conservation of freshwater resources, beneficial in water scarce regions like desert areas, like we have in India for like Rajasthan, etc. And LED grow lights, the one we used in the greenhouse facility on lunar habitat, can be applied on Earth. Their application could be energy efficient lighting for plant growth in greenhouses and vertical farms. Its output could lower energy consumption and improve plant growth rates. Lower energy consumption is very trending right now on Earth, and it is a very important point. And 3D printing is also necessary on Earth. Its application is on demand manufacturing of tools and parts. It's a very easy method to make tools and various parts of the systems. And its output could be reduced need for large inventories, quick replacement of broken parts, and customization of tools. Guidelines to be applied to daily life on Earth. The first one would be the efficient resource use, water conservation, in the sense implement water saving techniques like rainwater harvesting and grey water recycling. Water conservation is the most important thing right now, as we are facing lack of water. And also energy efficiency, use energy efficient appliances and renewable energy sources. We are also lacking energy, so renewable energy would be the best to choose. And the second one would be the sustainable agriculture, urban farming. Encourage the use of hydroponics and vertical farming in urban areas. In urban areas, we face difficulty to find soil areas like agricultural land, so hydroponics would be the best sustainable goal. And local food production, support local food systems to reduce transportation emission and ensure fresh produce. And third one would be the waste management, composting, promote household composting to reduce organic waste and produce nutrient rich soil. Their recycling could be implementing comprehensive recycling programs to minimize landfill waste. And fourth, health and well-being. Balanced diet, incorporate a variety of fresh homegrown vegetables into daily meals. And recreational activities include regular physical activity and leisure time to improve mental health. Impacts to sustainable development goals. The first goal is the zero hunger. Impact would be the improved food security through efficient agriculture practices and increased local food production. Uh, as we know that in the sense of Africa, we can help this goal to apply there. And the second goal would be clean water and sanitation, enhanced water management and conservation techniques, ensuring sustainable access to clean water. Clean water is necessary to avoid diseases. And the third goal would be affordable and clean energy. Adoption of energy efficient technologies and renewable energy source in agriculture and residential settings. As we are also lacking the energy, the third goal would be the affordable and clean energy. Affordable energy in the sense, we will use the renewable energy, and the clean energy should be supplied to everyone. And the fourth goal would be sustainable cities and communities. Integration of urban farming and sustainable practices into city planning, creating greener and more self sufficient communities. The fifth goal would be responsible consumption and production, promotion of sustainable consumption patterns and waste management practices. In the most urban areas nowadays, very pollution happening. So this goal could help them waste management practices. And sixth goal would be the climate action, reduction in greenhouse gas emissions through efficient resource use and sustainable agriculture practices. As we have done the agriculture practices on the lunar habitat, we can apply them on earth to uh, to conquer a good climate of earth. And life on land, the seventh goal would be the conservation of natural resources and promotion of biodiversity through sustainable farming and waste management. Sustainable farming is necessary nowadays, as everyone is talking about sustainability. So it is a very important thing. Waste management is also important to avoid pollution. And these are my references. This is my contact info. And thank you for your attention throughout my presentation.